it worked out really well. As I sat down, had a bowl of soup, and I started kind of drawing out the problem. And almost immediately, I kind of realized the shorthand for talking about the problem. That was essentially what we were doing here. It's actually the same screen we had up before. But now I think I have a better way of expressing kind of what we were getting at. And if I'm correct, I think the way we talk about it is actually really simple. The solution for any index is everything to the left of me multiplied times everything to the right of me multiplied. So I think we were totally on the right track with kind of looking at the left and the right side kind of split. It was just a matter of kind of phrasing it like a recursive solution. So let's take a look at our example, same one we've been working on for hours, and think of it in terms like this. So we start with index 0, and I say everything to the left of me, oh, there's nothing. So let's treat that like a 1 times everything to the right of me, which is a recursive function where we basically pass the array 2, 3, 4. All right. Now we move on, so we don't have to solve this just yet. So here at the first index, okay, so now we're over here. We say everything to the left of me. There's only one item in the array. So that's the number 1 times everything to the right of me. 2 times, sorry, not 2, geez. 3 times 4. So that's what we're going to pass. Second index. Everything to the left of me times everything to the right. Now we've been building this up as we've been going along. So we don't need to multiply all of these. What we need to do is take this answer times our current, which is 2. So now we get 2 times 1. Abdul Rahman, I'm not done with Twitch. I keep meaning to move to Twitch, but I just haven't yet. What happened is I went away and I ate a bowl of soup and I thought about it. And I realized that we are totally on the right track with how we've been kind of splitting things up. But we can phrase this problem a little bit more simply that maps to a recursive definition for how we're going to code this thing. And what I kind of came up with was basically saying, if we, at any given index, take everything to the left of us multiplied and multiply that by everything to the right of us, then we're done. And if you take that definition and you start that from left to right, you can probably go from the back too, it doesn't matter. If you do that, then you can build up to the correct answer. The only kind of weird part is you have to defer the execution of the things that happen to the right until you're able to do that without repeated math multiplication. And so to kind of walk through this again, it's very similar to what we were saying before. It's just a difference in how we think about it that lets us know how we can code this. So when we start with index 0, we have nothing to the left of us. So we'll just pop in a 1. To the right of us, we have a question mark. So let's come back to that. We move on to index 1. Now that's going to be our item here. And there's only one element in that array. So we don't have to do any multiplication. We can just take the value out of that array. That was everything to the left of us was just that one number. Now everything to the right of us is still a question mark. So let's just move on. Now we are at index 2. That's the number right here. It's everything to the left of us, which is going to be the value at the previous index times whatever this is. So answer 2. There's one math operation there. Times everything to the right of us. Now in this case, there's only one item left, so we can unwind this stack. So 2 times 4, our answer is 8 here. Done. So we can unwind this by saying, oh, okay, well, what was that times its previous value? Okay, 12. Now we can do the answer there. Okay, we got our answer for these two. Now, what is that here? 24. We can do that answer now, 24. And then we have our last element in the array, which is going to be everything to the left of us, which is 2 multiplied by the previous index, 6, times everything to the right of us, which is nothing, so we can pop it a 1, equals 6. Boom. Sorry, I got very excited about that. So does that make sense? It's exactly what we were doing before, and we've done it in a couple different ways. But the difference for me, at least what kind of cracked the nut open on this problem for me, was just this way of phrasing our solution. Everything to the left times everything to the right. Now we just travel. Now we have to code this. So I'm just going to go ahead and stick with JavaScript, and maybe we'll port it over Kotlin or something, maybe, depending on how well this goes. But I think this is it. I believe this is O of n. There's no division. And we don't have to do any sort of big data operations. So we do have to kind of keep some variables out here. You need to know the left and the right size. So that'll be 2 times the size of our array, which boils down to a size complexity of O of n. Yeah, that's what I'm thinking. So it's kind of weird to think about it, but it has this kind of weird, like, left and right kind of crossing each other kind of operation, which is kind of weird. So, I could be wrong on the there might be some room for optimizations here. I don't know. We'll see. Because, at one point I do kind of build this up from the left and I build this up from the right. But because I'm not doing this over and over and over again, I think that's just going to involve us doing basically 2 passes over the array, which in big O terms, we drop those constants because they kind of don't really apply to the growth of the curve. And so I think we end up with our O of n solution. But it's this back half that's kind of weird. We have to like defer the execution there. So I'm not quite sure how to code that yet. So let's see. All right. So what I want to do here is loop through every number, and we're only going to go through it once. I equals 0, I less than nums.length, I plus plus. This was driving me nuts the whole time I was eating soup. I was thinking, as it was in the microwave, I was thinking. First pass one going forward, second pass going backwards. I think that you're right. You know what you called it? You called it that you mentioned that there might be some sort of hint there. So that's great. Oh, sorry. I think I'm clipping the mic. I got so excited. And yeah, I think you're on it. Heck yeah, man. So was it like 4 in the morning? Oh, sleep good tonight, man. You earned it. Yeah, you even called it like talking about kind of, yeah, going from both sides. So I think that's it. Oh man, I'm excited. Clipping the mic. All right. So I'm going to do another method here called calculate. How are we going to do this? I'll move this in. Got a const for the result. It's going to be an array of size. That doesn't really matter in JavaScript. It's going to be the size of this nums though. We'll go through our array. And if items to the left, which is going to be, call it left count, equals I. If left count equals 0, then we can just say I equals 0. If I equals 0, then left sum equals 1. Sure. Left sum equals 1. Else, if see. So if it equals 0, then left sum is 1. Otherwise, left sum, I'm going to bring this out. Left sum, we can say just if I is greater than 1, greater than 0. Left sum equals left sum times nums at I. And the left side is easy. That's it. Hey Sherry, how you doing? Hope you're having as good of a quarantine as you can. You and your family are doing good, feeling healthy. This problem beat me up so bad, Sherry. It's been 2 hours. Abdul Rahman's been here, hanging out. Beat me up so bad. And then I went and ate dinner and scribbled on a piece of paper and then came running back to the keyboard and kind of realized that what I was missing was not so much an understanding of the problem, but a way of kind of expressing that, what I was trying to get at via code. So now I've sat back down on the computer and been very excitedly trying to figure out how to actually convert that into JavaScript. With mixed results, I guess. So what I'm doing is basically saying everything to the left of me multiplied together for any index. And we're going to build that up. And then on the right side, it's a little weirder because to kind of walk through this example here, we've got an array here with 1, 2, 3, 4. Oh my gosh. I struggled for hours. I had a really hard time with this one, and then I ate, so it's kind of like I've spent 3 hours thinking about this problem, and I had other things I'm supposed to be doing tonight, so I'm in a little bit of trouble. So hopefully it's working out okay. Speaking of, I'm still on of the day. Sorry, I'm chatting here in the background. All right. I'm gonna tell them I'm almost done though. So I'm feeling helpful. But yeah, it's been hours now, and this is gonna end up being like 20 lines of code. So it's everything on the left multiplied by everything on the right. Now the right side is confusing. So walking through this problem, we'll see that the left is really easy and the right is not. And we have a couple options for dealing with that. Maybe like walking through this backwards, and so this is going to be the tricky part. But I'll kind of walk you through what I'm thinking. So as we go from left to right on our input, all we're going to do is add up the product of everything to my left and everything to my right. Now, if it's more than two numbers that I'm multiplying together, I'm going to defer that operation because I know I'm going to be able to build that back up later so I don't do redundant calculations. I'm not sure how to do that yet. But here's what it looks like kind of in theory, on paper. We look at the first element. It has nothing to the left, because that's the first item in our array, and it has these three to the right. So I'm going to record a 1 here because there's nothing. I'm dealing with multiplication, so this kind of just keeps us neutral. So it's 1 times question mark. I'm going to come back to this question mark. I think I'm going to be able to fill that in later. We look at the next item. So we're taking everything to the left of me, multiplied by everything to the right. So it's just going to be whatever the prior step answer was, multiplied by the item, the one index to the left of me. So 1 times 1, or 1, multiplied by everything to the right of me, which I don't know how to do yet. So we'll stash that. We're going to defer that operation until we can do it. Next index is here. So all we have to do again is just take the item previous multiplied by our running product. So we've got a 2 there. Yep. So 2 times 1, okay. Multiplied by, now at this point, I only have one item to the right. So I'm not gonna do this math yet, just because I kind of want to see what it holds on. So I'm gonna go ahead and just treat this like a question mark 2, and I'm not gonna unwind this till the end. Now we get to the final index, and it's everything to our left, which is just the item previous to me multiplied by the running sum. So we get 3 times 2 for 6 times, because we're at the end of the array here, there's nothing else. So at this point I have everything I need to complete this problem and find the answer. There's nothing to the right, so much like the first time we ran through this, we just pop a 1 in just to kind of keep it neutral. Our answer is 6. Here, now we're basically going backwards. We go through the array once to the left and then once to the right. Okay. So now it's going to be 1 times my one item to the right, which is 4. Answer is 8. Do the same thing again. It's going to be 3 times the sum from the previous step, 12. And then again, 2 times the, I said sum, I meant product, 224. If we add this up, there's our answer. And I think that's how I'm going to code it too. So I'm going to build up a left sum, and then I'm just going to loop through from the right side and build up a right sum. Multiply those things together, and donezo. So I'm very excited. Hopefully I'm not like screaming into the mic. This just beat me up so bad. I'm very happy. All right. So here's our left sum running up. And here's everything to the left of me. And to do one better, I don't even need to keep like a left sum like this. I can just stash it right in my result. So if I equals 0, then we have a special case here where result at 0 equals 1. It's because there's nothing to the left of us, so we neutralize it. In every other case, it's the result at I minus 1. It's the item before us multiplied by our current. Oh, good, Ryan. Yeah, I think that was using the wrong microphone. I also did turn it up a little bit, but I also have gotten very excited. Have you done this one yet? And you missed it, by the way, Ryan. I did terrible the first time I tried to do this. Spent 2 hours struggling, didn't get it. Got close, kind of figured out the pattern roughly, but just couldn't get there. I took a break, ate some soup, drew some pictures on the back of a Dunkin' Donuts advertisement, and then came back supercharged and ready to just blow this thing out of the water. So I'm very pumped, very excited. And then I'm going to be doing some pair programming here over on Twitch with the Mad Viking God. So I'll drop a link or something to that. I don't know. That's going to be fun. I think we're going to be doing some Go or something. All right. So what I'm doing here. Oh, man. This beat me up so hard. So the way I'm thinking about this problem, Ryan, is that I'm saying I'm multiplying everything to the left of me times everything to the right of me. And I'm moving from left to right. And I'm doing this in 2 passes, which still gets me the runtime of O of n because that constant 2 drops out. So the first pass, all I'm doing is building up my left. And then I'm going to come back and build up the right, multiply those things into the same array here. So if I did this right, I'm just going to do this one more time. So I'm trying to do better about making sure I know how to solve this thing on paper before I try to code it. So if I can't do it by hand, how am I going to automate it? That's a lesson I need to internalize. So when we're at 0th index, there's nothing to the left. So we're going to throw in a placeholder for 1. I don't know what the right side is. That'll be the second pass. Index 1, it's going to be whatever is in the current index. So result at I. No, sorry, not result at I. Nums at I. So our current index multiplied by whatever we stashed in our results in the previous step. So it's going to be results at I minus 1. Oops, and let me times that. So to say that again, the result at index 1 will be the number of my current index multiplied by the result of the previous operation. So that'll be 2 here. All right. And done. That's half of it right there. That's half of the solution. We'll go ahead and keep running that out. I'm going to leave that multiply sign to show that I haven't done the right side yet. 2 ends up being 3 times 2. Cool. And the final index ends up being, did I do this right? Left and then, no I didn't. It's 1126. Yeah, my bad. So, as always, I'm getting tripped up on the numbers. Okay, 1126. And so if I run this algorithm now, I expect to get my results populated with 1126. Then we're going to run this thing in the opposite direction. And I might need a second array here. I haven't thought that through yet. In this case, let's go ahead and start out with nums.length minus 1 for our iterator, and we'll go while I is greater than or equal to 0, and this time we'll decrement. But it's going to be the same thing. If I is equal to the length of our input minus 1, which is to say it's the last item on the right, then let's just multiply in, or yeah, right now I do have to do 2 arrays here, so my space complexity is not great here. So let's go ahead and change this to like a left result and right. Sure, just call it left. So we got a left and a right. Yeah, Abdul Rahman, I'm doing the same thing just right now. So I just decided to split this up into 2 arrays because I was getting twisted. And this time it's going to be a little different. It's going to be whatever our current item is plus the item to the right plus 1. And we do need else's here. And I equals that, so we can just make that a little slicker, just like that. Right at, sorry, checking to see if my buddy's online. I'm late for another streaming date. All right, left and right, there we go. All right, so at this point we've got all the left numbers figured out and all the right. So I'm going to unwind this backwards and kind of trace through this from the other side. If we're at the last index, there's nothing to the right. Need an else here. Then it's going to be a 1. So we can calculate our result at that point. Now, coming back through, it's going to be our result from here, which is why I have to do 2 arrays, because I always need to know what this one was. It doesn't need to be an array though. I can use a variable here. So I think I'm going to try to do that. If we can prove that this actually works the first time, then we'll do that optimization. So this time it's going to be our number to the right, 4 times 1, so 4. And then we got our answer. Again, same thing. This time it'll be 3 times our result here, which is 12. And finally, it'll be 2 times our result here, which is 24. So we get 24, 12, 8, 6. 24, 12, 8, 6. So, yeah, did we do this? So we calculated our left results, we calculated our right results. There's no division. We're running in O of n time. And let's see here. Now we have to basically go through the arrays and return the result of both of them. So basically I'm just going to do another for loop here. Let's reuse the variable I because I'm a jerk, I guess. I don't know. I less than nums.length. Using the same variable name, 3 different contexts and the same function. Great. Definitely don't ever do this at work. All right, we'll finally have just one more array. Why not? We'll clean this up in a minute. Result is an array. And result at I is always going to equal left at I times right at I. So no recursion necessary either. We kind of did that by basically splitting the problem in half here. So that's cool. So I'm really happy with the runtime here. Somewhat happy with the space complexity, and I think we can get that down. So let's see if we got lots of syntax errors. Yep. Runtime error. You're gonna put this line 3. Oh, I got my stuff up there. I'm so psyched right now. I thought that I was just gonna have to give up today. We're only halfway through. The problems have definitely ramped up in the last couple days, no doubt about it. So I don't know if I'm gonna be able to continue this because I can't spend hours. I said this last night. I was like, I can't spend hours doing these problems every day, and here I am again. Did I not return the answer? Jeez. These kind of problems I can live with. It's the logical flaws, like the other day, the contiguous subarray, where I had a big logical problem. And so Abdul Rahman, this is exactly what you said, where somehow my answer list is backwards. That's hilarious. I literally did. You and I coded the same thing. Exactly. That's funny. So what did I do here? I think the deal is that when I set right at I is counting backwards, not going forwards. So the cheap answer is just to reverse this, but is that true? Is that true? Did I mess this up? I'm counting down from the right. I minus minus until it gets to 0. So I have the right, then right equals 1. I'm looking at my little cheat sheet here, which is mostly just scribbles. Otherwise, it's the right result at index I. Now we're setting that to nums at I, which is coming from the left, multiply by our right number at I plus 1. That looks good to me. So how did I get this exactly backwards? How on earth did that happen? I'm just going to print out my left and my right and see what I did wrong there. And also, I'm going to bring back my table here so I know what I expected for those results. You guys ever do that? Like undo, 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 copy something and then paste it? And sometimes you actually hit a button and lose everything you did. It's dangerous. I don't recommend it. Alright, so here's what I expect my left to be. I want to see 1126. For my right, I expect to see 24, 12, 4, 1. And it looks like both of these are going to be reversed. And I don't really understand how I did that. That's weird. But so left is left and right is right. So 1, 2, 6, 24, 6, 6, 3, 1. 1. Well, what the heck? This is not right at all. I'm surprised it even got the right answers. 6, 6, 3, 1. Your input was 1, 2, 3, 4. So how on earth did I get that? Alright, well I feel like the algorithm is good. So I goofed something up in here, I think. So I'm gonna resort to our old friend, because I didn't do this in code again. I did this in Leet Code, big mistake. I should have stuck with code, it was nice yesterday. Bailing. Whoa! Something scared me. I think Fuesto, you followed. We finally figured out what the noise was. If someone follows the channel, I guess, while I'm streaming, it does this super loud noise. It scares me. All right, and same here, bailing, returning 1. All right. Now here we're gonna say setting left at I equal we'll just do the whole thing here. So I only want to do this once. Same thing here. What was the problem? Because it's looking like you and I did the same exact thing. Setting right. Our multiplication was including the index itself. Oh, geez, and that's, yeah, that's the whole point of this exercise is we're not supposed to include ourselves. It's supposed to be the one previous. Man. Wow. That's funny. I have +1. Yeah, I think you are totally dead on about that. That's funny. Wow, that's so funny that we got that same problem there. That's hilarious. All right, let's see what we got here. Did I fix up the statements? 1 + 1, 1 + 1. Nope, this should have been -1. Let's not even look yet. All right. So here we got bailing returning 1. Then we set for setting left to 0 is not correct. It should have been setting left to I, so that was correct. And down here should have been setting right there. All right, let's try this one more time. I updated the wrong set of numbers in the console.logging, but I think the code looks good almost. How did this even run? What the heck? JavaScript. All right, I -1. Okay. Let me send the Mad if I can got a link here. I don't actually know how to tell what the URL is. Okay, here we go. I found it. This even run? Oh, Inception. There we go. All right, hopefully we get the Mad if I can got it here in a second. Round of applause. We're going to be twitching over on his Twitch in a minute here. But man. All right, so where were we? Now we got the right answer. So I've still got something wrong in my setting right. What did I do here? Console.log. Yep, I left out a number. Should have been right +1. I'm so happy about this. We got the right answer. It could be optimized, but I'm running late. Mad if I can God, if you're there, you should drop a link to the Twitch stream. His name is spelled. Let's see here. Twitch TV/Mad Viking God, is that right? Hey, yep. That is right. So yeah, go throw him a follow right now. I'm not logged in. I use Chrome generally. But it's MADVIKING And we've been doing some pair programming there. And we're about to do another one as soon as I finish this problem. It's been a very codeful day. All right, let's go ahead and submit this. Oh, you know what? Let me try this 1-0 use case. Let's see how we do here. That's the right answer. Okay. So if we submit this. Oh yeah, you know, I think I can actually chat over here and say Mad Viking God. Duh. Okay, I put it in the chat there. All right. Yeah, man, I am so pumped. Okay. Let's go ahead and take a look at the details. Unfortunately, I'm not going to convert it to Kotlin because I'm just out of time. Spent way too long on this. But had a lot of fun. Thanks so much for sticking around. I really hate that I took a break there. That really bothers me. But until he pops in here, I'm going to go ahead and try to clean up a couple variables. So I think that we can get away with only having one result set here. Let's see. And by the way, great call there. for solving the mystery. That could have been a whole other one. Oh, hey, there we go. There's Mad Viking God right there. Everyone say hello to Aaron. We're going to be doing some pair programming here in just a few minutes over on his Twitch channel, which I just put the link in there too. So there's a lot of latency on my channel. I was just talking about how you and I are going to be pair programming in a minute after I solve this problem. And then we just solved this problem like super bosses. It was really tough, and we nailed it. Nailed it. So I was telling people to throw you a follow. And then I said that I was going to keep optimizing this problem until you popped in, and you popped in. So I guess I'm not going to collapse this left and right variables, but I know that, let me see here, if we run this again, that we could trim down the memory usage, and that would probably help things run a little faster. Overall, though, I'm happy with the results. So we're definitely in the top half of solutions here. I think that if we manage to get that down to one array, then we would probably get like right in here with the best solution. So I'm really happy to see that we got the best solution there. Memory wise, same deal. I don't actually see where our solution is. Oh no, Abdul, you were on the right track from the get-go. You called it and talked about going from the left and from the right, and that's exactly what we did here. So that's super exciting. And it's like I don't know, 5 in the morning for you now, so I'm gonna head over to Mad Viking God's channel now here. We'll regroup, and then I'll catch y'all on the flip side. Later.